On page 284 and 285 we're looking at section 19.2 entitled Vector Geometry. Well, let's see what that means then. This is really easy. Well, some are really easy anyway. Look at question 1 on page 284. It says this is a kite. Well, that's good. So, right, A, B, C, D, 4 vectors there. I can see that D and A must have the same magnitude. If it's a kite, then AB equals AC, and likewise BD equals CD equals BD in length. Therefore, vectors C and B must be of the same magnitude. Obviously, they will have different directions. Anyway, that's the background to this. Write the vector AD in terms of A and B. AD, so I want to go from there to there. So essentially, my brain's going to say, you go from there to there, please, direct. There's a reason why it's crashed straight away. Right, let's just try again. You go from A to D directly, and that means you need to have an arrow on it, so that's A to D. How do we go there? We go from A to C and C to D, therefore that's going to be A plus B as little vectors. Now, write the vector AD in terms of C and D. Well, I've gone around this way. I can also go around this way. Now, look at this. To go from A to D, I'll go from A to B, which is minus D, and then from B to D, which is minus C. So that's going to be minus D minus C, coming against the flow of traffic, as I like to say. So it's be minus D minus C, or minus C minus D. Write the vector BC in terms of A and D. So it's asking me to do this from B to C, go in that direction, hence the arrow, and it wants me to go in terms of A and D. Well, let's just take a look. From B to C, I must go up the D and down the A in the direction shown. So essentially it's going to be D plus A, or you can call that A plus D if you want to. Let's make that little A a little bit bigger. It's not that small, is it? So D plus A, or A plus D. Alright? Next one, write vector BC in terms of B and C. Right. So I've got to go from B to C. Therefore I must go down here to D and up there through the B. So I'm coming against the direction of C. There's going to be minus C. And I'm going to come against the direction of B, which is minus B. Therefore it's minus C minus B, or minus B minus C. Use any of your answers to write A in terms of B, C and D. Right, how do you do vector A from A to C? I've got to go down here, and up there. So I don't know how many answers there are. So let's just write it fully then. To go from A to C, I must go from A to B, and then I must go from B to D, and then finally go from D to C. And as you can see, I'm going from A to C. There's A, there's C. So I've got the direction correct. So let's just do that mathematically then. A to B is known as minus D, because I'm coming against that traffic, so that's going to be minus D. B to D, that's going to be minus C, so I'm going in the opposite direction. And then I'm going from D to C, which is against the flow of the traffic of B, so that's going to be minus B. So if I want to write it nicely, I'm supposed to get it into, order. Be minus B, minus C, minus D. That's the same effect in terms of the algebraic arrangement of those vector sums. Alright, so that's that. That's a kite. Let's try another question. This is question 2 on page 284 again. Now, if AX in that order is defined as 2A, vector 2A, and BX is defined as A plus B, find AB in terms of little a and little b. Well, okay, bit of a mouthful. Now look, I've got XA there. So if XA equals 2A, therefore AX has got to be minus 2A. Is that alright? If I go up one-way street, and my street's called 2A, if I come down the other way, I've got to go minus 2A. Right, I'm not drawing anything, I'm just playing with algebra now. So AX is minus 2A. Now look what I've got. I've got AX, so look, that way, plus XB that way. Look, I've got A and B. That makes AB, doesn't it? Alright, so AB equals AX plus XB. Look, start with the A, finish with the B. Now we just put in the vectors. What is AX? Answer, minus 2A. What is BX? Well, lift it straight from the question, A plus B. So I'm going minus 2A, then go plus A plus B. So minus 2A plus A, it's just algebra now, it's going to be minus A plus the B. Or better still, starting with the positive values first, B minus A. Alright, so that's question A done. Let's do a different colour for B. We do it down here. If YC equals little c and YD equals D minus C, find CD in terms of C and D. Right, so big C, big D in terms of little c, little d. Alright then. So I want C to D. How are we going to do that? So C to D must go C to Y in that direction, followed by Y to D in that direction. Look what I've done. I'm starting at C, finishing at D. So what do we got here? CY then. Well, it's going to be the reverse of YC. So that's going to be minus C, isn't it? In terms of vectors. And YD, again, lift it straight from here because I'm not going to change direction there. I'm going in the direction of YD. Therefore, I must add on D minus C. What have I got? Minus C and minus C. It's just algebra now. So it's minus 2C plus D. And that's that. And we use a different colour again, which should stand out, yep, for part C. Now ZE is F minus 2E. Don't worry about the complexity of the vector. Just note the direction. And FZ is 4F minus E. So find FE in terms of E and F. Okay, so FE, that's where I want to go. I want to go from F to E in that direction. So let's have a look. I've got to have FZ first. I'm starting with a point called F somewhere on my diagram. So I want FZ followed by, well, I want to end with E, don't I? Plus ZE. Do you see that? So I'm starting with F, finishing with E. So now we just substitute the actual vectors. FZ is defined as 4 lots of F minus E, then plus whatever this, what does that say, ZE is. Now ZE again is facing the right direction for us, so that's going to be F minus 2E plus F minus 2E. Now just pick up the algebra. If you didn't know we were doing vectors here, it would be a matter of grade E or F to simplify this simple expression here. However, in the context of vectors, you're looking at grade A or A star. Anyway, so 4F plus F is 5Fs, minus E minus another 2 E's is minus 3E. And that is question 2 done. I think I'll do question 3 in this video and then pause for reflection. Let's check this over because it was a bit too easy. F to E, so start from F to Z and then go Z to E and then cancel out the Z's. Yeah, easy peasy. Here is, looks like a cuboid if you look at it in a funny way. It's a lot easier if you see it as a hexagon with center 0. So for example, OA is little vector A, AB is little vector B, etc. Now, list all the vectors that are equal to little a. Okay then, well, let's do little a. A goes in that direction, and since this is a hexagon, that's also A, that's also little a, and that is also little a. So I'm not going to list them, I'll speak them out. It's CB, not BC, look at the direction. It's DO, not OD, and it's EF, not FE. Alright, that's all the A's sorted. Now what about the B's? Let's do a different colour, so I'll underline that in red then. So the B's, so B goes from A to B, there's another one, O to C, there's another one, F to O, and there's the last one, E to D. Alright, so that's all the 4 B's. And now it says list all the remaining vectors in terms of A and B. In other words, the vector from F to A or A to F has to involve a B plus an A, because there's no direct route to cross there using a different vector. There is no vector C, for example. So how do you get from F to A? Again, there's a number of answers. I can either quote it F to A or A to F. Let's go F to A because it just looks easy. How do you go from F to A? Well, I want to go from F to O and O to A. Alright? Again, this is me showing my steps. F to O, then go O to A. Is that alright? Again, the F to A is what we're doing. So put in the vectors. F to O is a B in the direction of the arrow, and an O to A is a little a. And there it is. That's basically A plus B. Very, very easy, isn't it? So that's A plus B, and let's label that in a different colour. It has to go for a neutral black colour. So in that direction, F to A, that's going to be A plus B. Are there any more A plus B's? Yes, there are. From D to C, in that direction, look, I've gone from D to O and O to C. What does that mean? Little a plus little b. There it is again. What about this one here? What about E to O? E to F is A, F to O is B. Therefore, this one is going to be A plus B as well. And I think I've got one more floating there. From O to B, it's simply A plus B. There it is, straightforward. A plus B. Now I'm not going to list them all. I've done it on the diagram, but I've only listed the first one I started with, which is that one just there. So I'm happy to leave it like that. All right. Remember, vector diagrams, vectors shown as little arrows on little lines representing the direction in which you must travel. If you come against the line, it'll be like minus A or minus B or something like that. But you know, the arrows do mean something. Clearly, look at the original question here. We have A in that direction only, O to A, and B in that direction only, A to B. Alright, so I'm going to stop there. That's a long enough introductory video in terms of vector geometry, and it's still rated grade A/A star. Alright, see you later in question 4, etc.